Uh, okay. I usually tell this before I start every presentation that I do. None of these slides were done by me. Like anything and all that you actually see right now moving forward is like all AI coded, AI driven, whatever that you want to call it. But conceptually, the flow, the use case, everything else apart from the code and the slides is like AI generated. So I take no credit for the work, but I take credit for actually putting this together and also the thought process around this, right? So yeah, I usually give that as a bit of a heads up. But don't worry, I always double check whatever that's there. So every slide is being double checked. And every code also has been run and I've seen that it works, right? And why I usually follow this is because I've come to a point that I can tell, oh, the things that I work with, the things that I know is what I usually end up putting up on slides. So if it makes a mistake, I know that this is wrong, right? So just putting that out there before someone claims that, okay, this feels like AI generated, it is, right? Just putting that out of the way. I usually tell this every time before I start a presentation. I think I've been doing AI generated slides from way back from 2023 onwards. So just a heads up. Cool. I'm going to start sharing my screen. Again, a bit of housekeeping. If you have any questions, do ask on chat or you can unmute and ask also. Okay, I'm going to stop sharing my video. I'm going to start sharing my screen. I hope my screen is visible. Just if you guys can confirm via chat, that will be helpful. But according to Zoom, it says it can, but just checking if it's clear enough. Is everything okay? Is my slides visible? I'm going to assume it is, yeah? Okay, right. Thanks a lot. I'm just going to take a chat here also. Okay. So again, the session that we're actually doing here today is like agents and workflow automations. Again, this is a bit of an umbrella term. There's a lot of things that can come under this. So I've actually scoped it in a way which is more developer focused, given the nature of the community and the nature of the people who usually end up joining, right? Slides are on GitHub. I'll actually share you the link at the end of the session and right before we actually go into the demos. But yeah, so how this talk has been structured is there's going to be like 6 primitives and a couple of wirings in canonical wirings on how things are going to be, and a bit of a use case that's been done in 4 different ways. And the framework that we're going to be using is Mastra. Mastra is a TypeScript framework, like agent building TypeScript framework. Why I chose TypeScript is TypeScript has been like a bread and butter for me for like a very long time. And usually people end up doing web programming a lot, so they're all familiar with JavaScript, TypeScript, but the same concepts is the same across all different languages, right? So who am I? My name is Mithushan Jalangan. I go as the co-founder and CTO of Asingdot. We have companies and entrepreneurs or early stage founders with their tech products. We usually work as like an extended CTO service where we help them consult and build products for them. Currently, I'm mostly focused as like an AI engineer or like consultancy is what I usually end up doing. I've close to that's actually outdated. I have close to like more than 9 to 10 years of experience working with like early stage startups to being part of startups to actually building systems that have been actually used by people. Recently moved to be like a very Cloud Code user. I've been like a cursor user for a very long time, but recently I jumped the gun and I became a very heavy Cloud Code user. So that's why I actually gave a bit of a heads up early on that everything that you see is all AI generated, but human reviewed. I usually end up being a senior contributor or like an individual contributor, like an IC as people would call it. So I usually end up working directly then rather than managing teams. Even if I do work in teams, it's very small teams. I specialize in like AI native development for building software and building products as well, right? I do have a bit of a background in terms of I do have like a software engineering degree, but I would coin myself to be like a self-taught programmer because I ended up knowing things, most of the stuff that the university taught me before I even joined university, at least like 60% of the time. So that curiosity still leads to me. So I, even though these are things that I have put up, I do a lot of other stuff also. Just wanted to put it up there. So what we're going to be actually doing is the entire talk is going to be on how do we build agents that could actually write code. Essentially, if you look at it, most of the time, if you look at any open source maintainers or if you look at any developers in general, bugs are predominantly or maintenance is predominantly the main thing that they would do depending on the stage of the project, right? And right now, people have actually started writing code with agents or like with AI. So I actually wanted to use that as an opportunity to explore in terms of how we could potentially build something of that nature, right? Um, it's not going to be like a full working thing, but rather some just to show you the principles in terms of how things can be made, right? So what we're going to be doing is we're going to be building a multi-agent issue triaging system, right? It's going to be implemented in 4 ways, like I told you before. We'll work with different stages of how we can actually be building this. I'm using Claude 4.5 because it's comparatively cheaper using Open Router, and we'll be actually using 6 different primitives from like doing a single agent to like a supervisor based agent, uh, which is essentially an agent with other sub agents, right? So just wanted to build the same thing, or like have agents very specific for doing very specific things, so we can actually go from like a single agent to like a supervised agent, right? So if you, the entirety of this talk is like workflows and agents, right? But the majority of this is around agents. But if you look at it in simple terms, workflows are scripts with LLMs, whereas agents are LLMs with scripts. This would come into, you will get a better understanding more along the slides as we go ahead. So if you look at it, if in the fundamental level, intelligence right now is actually coined using your use of an LLM, right? LLMs are not geniuses by default. They are basically large language models, right? Which is essentially a model that has been trained on like a large corpus of data. So what's essentially it's actually doing is an LLM is like predicting the next possible token, right? So for an example, if you say something like the cat sat on the, it's like a word puzzle game, right? It just tries to predict whether it's actually going to be like the mat, floor, couch, or the ground, right? Or possibly anything else, right? So for an example, if someone actually asks you to play a hangman game, you start guessing what exactly, or like a word puzzle game, you start guessing what potentially could that be based on the surrounding, the context that you actually have been given, right? That's the same game an LLM plays, right? it's not like a very intelligent system around it, but the harness or the systems that you actually put around it is what actually drives its intelligence along the way, right? So that's the one fundamental understanding that you need to know, is that LLMs are just predicting the possible next token, right? It's not a very fancy thing that actually gets everything right. So that's why you kind of hear people saying, okay, ChatGPT is better, Claude is better, Grok is better. It depends a lot on how the model has been trained, the environment it has been exposed to, the context, and also the prompts that it has been given, right? So just that's the most fundamental thing that you really need to understand. Why is because different models perform differently with systems, right? For an example, you're using Model X and it's working very well in your development and all of those stuff. But the moment that you actually move to Model Y, it actually breaks. You can clearly see this if you work with a couple of different frameworks. Sometimes it would end up working properly on OpenAI's models, but it won't work on Gemini models, right? Things like that. So it really depends exactly on how you treat this, right? So that's something that you actually really need to understand. Yeah. Anyways, so if you look at it, agents, even though the word agents has been widely tossed around, if you look at it, they're basically systems in general, right? There's this very nice blog post under the title "A Visual Guide to Agents." I think everyone should actually read that as a listing, right? Because it actually goes to in depth around, not in depth, but actually gives you the first primitives of how an agent can be thought in terms of a system, right? So if you look at it, an AI system or like an agent has always been something that has been perceived to be like, or viewed to be something that actually understands the environment, uses some sensors, and actually acts upon it, right? You can actually take this as an analogy for you to understand yourself also. So some people say that you get very angry very easily. Some people say that you show very affection very easily. Some people say that you lie is the first thing that you do, right? All of this actually comes around the fact on the environment that you have been brought around, or the experiences that you actually have got, and all of this, right? Some people who play cricket differently, some people play different, they're left-handed, right-handed, all of those stuff, right? So if you picture yourself as like an AI agent, you will understand environment, the things that you actually observe is what you take in, the sensors on how you actually perceive that, then your actuators of how your tools are being used, and all of those things that kind of affects you, right? So if you think about it, we could be possible machines as well, if you put it on that perspective. So the same theory actually applies around when you're actually building agents, right? Because if you look at first principles, you're just building a system that actually has some access to separate tools based on its intelligence would do something, right? Say, for an example, I give you an axe. Uh, what you do with the axe is up to you. Whether are you going to chop down trees and sell them, or are you going to do something very bad about it, right? It totally depends on what sort of reasoning and how you're actually using it. So if you look at six primitives, if every framework, every agent framework actually follows this. So I'm using Mastra, but it's the same for like LangGraph. If you are like a Python person, LangGraph, LangChain is probably the first things that you have heard of, or even the Google ADK, like the OpenAI agents. Mostly people started being Python first is because that's where like ML and everything came into play, right? But people over time also started adopting it as like JS framework is because Python helps you like to do stuff, but people also realize that most of the stuff that's there already on the web or in production is probably written in Node.js or Go or something like that, right? But anyway, coming back to this, if you look at it in like the primitives, you actually have the model, you have the tools, you have memory, loops, controls, and then you have evals, right? These are essentially, if you look at it, what makes up any AI system, workflows, agentic systems that you probably might be doing, right? Each of these might have different names depending on the framework that you use, but in first principles, this is how it is. So memory itself is a very big topic that probably I won't dive deep into, but I'll actually touch a bit upon, right? So what is a model, right? Basically, the model that you would call it is like the LLM itself, right? It's the one that actually kind of predicts, or like the LLM is like the brain's function, right? It helps you plan, allows you to act around things and all of those, right? So if you look at mostly if you look at most of the framework, they have a way that you can actually use the model and you can prompt the model, right? So I'm taking this as an example to introduce you to something called the Versal AI SDK. That's the predominantly used like AI SDK or like the SDK that's used to actually interact with all of these models, right? So there are different types of models that are closed source and there's actually open models as well. Most of the time, what happens is you actually end up sending an HTTP request to this particular hosted model, and then you send it with a prompt and you actually get a response back, right? There are cases that you probably might even run the model locally, right? Something using like Olama and all of those stuff, right? So what this model is basically the LLM itself, right? How are you calling the LLM? Is a way that the SDK kind of operates for you, right? Because if this generate text is like a helper around a lot of things that's happening behind the scenes, right? It's actually handling, taking care of streaming for you, taking care of the HTTP request that's been sent across to the model, and possibly internally this generate text actually handles tool calling as well, right? So each completion is a sequence of words that have been forwarded from the model itself, and then it's actually been combined together at some point of time, depending on how you're using it. One thing that you actually have to understand is an agent loop is actually built on top of a model, right? If you look at an agent loop, it's actually a series of calls that's been made until the model is actually happy with whatever it's been done, right? So next thing that we'll actually talk about is tools. Now, tools, if you look at it, are functions that you would give to a model to perform a very specific action, right? So we've introduced models, we have introduced uh, tools, right? One or two of the six primitives, right? But I told tools are functions that you actually give, right? That's true in one way. But actually, what if you look at it, the model doesn't really, you don't pass your JavaScript function or your Python function into the model. What you actually end up doing is you actually end up sending a type schema, usually JSON schema, to the model, asking or telling it that these are the tools that exist. Depending on the given task, what tool would you execute, right? Or would you not execute these tools, right? So what actually happens behind the scenes is like or we would usually call this like an augmented LLM, of how the industry is actually calling this, is you give an LLM tools that it can actually act upon, right? So when you define a tool, the most important thing that you actually have to do is you have to actually give it a proper description, and you have to also give it any sort of schema that you would potentially use to actually get information from, right? So the tool is basically a bridge between cognition and action. Let's assume that you say that I want to build a house, or like I want to write code, right? The tool that you would potentially use is, okay, you need some sort of like a laptop or a computer to do things, right? So tool is basically your laptop in that context, right? But if you want to write something, the tool is basically your pen and or possibly a paper. Let's say, for an example, if you're using like all of these coding agents like GitHub Copilot, you know for a fact that what actually happens when you go give it a prompt is it actually reads, or even if you just go to ChatGPT, right? What it actually does, or like even Claude, when you actually upload like a PDF or a Word doc or an image or whatever it is, it first reads, right? The same thing that happens when you're doing a coding agent also, it actually first reads the file, right? So for you to actually read the file, you need a way for it to read a file. So read file, write file are different tools that most of these coding agents actually have, right? They actually have these own primitives of actually writing their own tooling around uh, depending on the operating system. So one model is the LLM tools is basically a set of schemas that you would actually give to the LLM to tell whether it should be called or not, right? So I'm still in this tool is because one thing that I want to say is the LLM is not the one actually executes the function. It's always the runtime that actually executes this function, right? So remember the generate text or stream text, depending on how you want to use it. There's also another thing that actually says tools, right? Essentially, the runtime is the one that's actually responsible for you calling the tool itself, right? So the LLM doesn't call the tool, the LLM just tells you whether this tool should be called or not, right? So just keep that in mind. Another thing about agents is you need to give it memory, right? Memory is basically things to remember by, right? Because each call that you actually give, it forgets, right? Every new call that you kind of give, it kind of forgets, right? So in Mustard, there is a lot of primitives and storages that you can use, right? So in first principles, memory is the discipline of carrying context. The word context should be well known for you guys moving forward, is because everything around moving forward in the entire agent development, I think context memory is some of the hype words that people are using a lot these days, right? So there are different ways that you can actually define memory. Memory can be short term, memory can be like in context, or memory can be actually long term, or it can be retrieved from different documents and all of those stuff. I think the most popular term that people are aware of is something called retrieval augmented generation, or RAG. So RAG is not memory, but memory can be implemented by using RAG as well, right? Where you might write your think of it as think of it as your notebook, right? If you don't remember something, you actually go ahead and look at your notebook, right? So the same way is what memory is for agents as well. It's a tool that they can actually use, or like possibly a tool that they can actually use to go ahead and find all things that it should remember. If you want to keep in context memory, usually what you end up doing is you pass the entire message history to to your agent itself. I don't know if anyone has done this, but if you just go to ChatGPT Claude right now, inspect elements and start having a conversation with it and look at your network tab, right? And you'll notice that every message that you actually get is actually being returned as JSON, right? That possibly might be going into the agent's next call as well, right? So memory is basically something that the agent uses to remember, whether it has to be a short-term thing or long-term thing for it to retain across different histories, right? Why memory is quite important is that's what it actually makes things a bit more personal, right? For an example, I talked to ChatGPT around how my life is today, and I kind of ask it like the day after tomorrow, um, how was my work on Monday? If it actually tells that okay, it doesn't remember, it's a very bad experience, right? So because of the need of like personal assistants or the use cases, the different personal assistants, or for you to actually understand different um, preferences across conversations, right? Memory is something that's actually being very widely used a lot. And if you start to make uh, applications for businesses, when you start doing personal or like co-pilot sort of applications, memory is something that's important that you should understand, right? So the other thing that's there is when does the agent actually stop, right? So if you look at it in principles, agent, the word agent is actually an implementation of a paper called React, right? It's an actual paper that was actually published in 2022. It's reasoning and acting in a large language model, is what the paper kind of told across, right? If you're really interested in understanding on how agents are kind of derived or made, at least in the early stages, you should really read the React paper, right? So one of the stopping conditions that if you look at the stopping condition is basically like an if condition, right? Essentially, just think of it as like a very big while loop that it's running, and when the condition is actually met, it stops. For an example, if you start writing, if you ask 1 plus 1, what is 1 plus 1? If if the agent decides to use Python to actually write the code, when the Python code has actually been executed and it has got an output, it can decide when to stop. There could be cases that you probably might want to stop it as well, because that sometimes if you see there are long thinking contexts, the agent might start repeatedly calling on loops, the tool calling again and again. So that's when you kind of have to have a bit of a control and a bit of a loop that in terms of when it should stop, right? In master primitives, it's mostly used by something called stop when, or like stop when the count is 10, right? Basically, what it translates to, stop when you actually have done uh 10 tool calls, right? See, for an example, way back in 2023 or 24, I can't quite remember, all like if you have used Cursor or Copilot or whatnot, it doesn't make more than 25 tool calls at one given time, right? If it's more than 25 tool calls, you actually have to stop. You have to type continue and then only it'll actually continue. So those are guardrails that actually prevents the agent of doing autonomously continuous things that probably might not yield good effects, right? This is very, if you use Cursor a lot, if you use Cloud Code a lot, you'll actually notice that it actually even self corrects itself. I've been doing this for a very long time. I should stop, right? These are things that have been built into the system prompts that actually kind of understands when the stopping condition should be, or it can be very mechanical things. It stops based on conditions and whatnot as well, right? Uh, So if you look at how this entire loop thing would work, is let's assume that I actually ask it a question in terms of the project that we are going to be working on, right? It's going to be a complete reasoning based thing that depending on the model that we would be doing, is assume that I actually ask it to triage issue 5, which is basically performance compared mixed with like API request, right? The command is basically saying that triage issue 5. That means check what's actually wrong with issue 5, right? The first thought process it actually might have is, okay, I need to fetch the issue body, right? Before classifying. So the action it will take, its first thought process is actually fetch the issue. Then it might call a tool called get issue. Then it actually observes, right? Okay, I have got the results for issue 1. So it actually reads this and understands, okay, this is what I got. Now it actually does another pass, right? It actually says, okay, I have got the observation, or now I need to act upon it, right? Then it actually goes through another loop saying, okay, this is what the issue is. Then it actually decides that it actually needs to classify this. It actually marks it as a bug. Then based on the response of the tool, it actually says, okay, now it says I need to add another tool. Like it keeps on going, right? So basically, kind of based on the loop it has been configured to, it takes its own input, puts it back into the LLM again, tries to reason if it's done. If it's not done, it keeps going. If it's not done, it keeps going. At a point when it decides, okay, I'm all good with this, then it actually stops, right? Essentially, that's what the loop is, right? You kind of do you give it a prompt or whatever it is. It actually thinks through it. It decides what action needs to be done if there are tools given. After the action has been done, it actually observes or basically looks at what the tool response it has got. And then it actually decides, okay, am I done or am I not done? Right? And it keeps on continuing. So it might keep on continuing unless otherwise you actually give it like a stopping condition and all of those stuff, right? That's what we spoke of earlier, right? So usually max iterations is what basically stop when was before, right? Or like tool results or reason for it to stop and all of those, right? If you look at it, most of all of these agents right now actually run a variant of React, right? The paper React, right? The mostly the differences are going to be the tooling and the prompting and the stop conditions that's happening. Essentially, if you look at it, that's what everyone would be doing when you're actually shipping agents and what, right? Okay. So another thing that you actually kind of have to understand is one of the six primitives is actually control, right? There are two ways of control that actually happens, and this is what actually makes workflows and agents different, right? So it actually depends on who's actually picking your tool. Is it the code or the model, right? That's where majority of the control lies in, right? If you look at it, workflows are systems where the LLM and tools are orchestrated in predefined code paths. Agents are systems where the LLM dynamically redirects its own thought process for tool usage, right? So in essence, is your system going to be like a workflow or an agent is dependent on who has control, right? Or where are you going to delegate the control to? Is it going to be the code or is it actually going to be the model itself? Okay. That's the most important thing that you actually kind of have to understand. In the premise or in the use case of we building like a triaging agent, sorry, that word actually slips my this thing a lot. Are we going to actually define how things are going to be? So for an example, if you look at the previous thought process, it actually decides or classifies whether it's going to be a bug or anything based on the issue that it actually does, right? So it first reads it and then it actually classifies it, right? So it actually decided its own tool calls. But you can actually do it in a bit more of a code way as well. First, you can actually classify, then you can actually see what the kind is. If it's a bug, then you actually handle the bug. You handle it as a feature or you close it as a duplicate, and then probably if it's not any of this, you actually go ahead and check for information, right? But if you give that to an agent, it's basically going to do everything by itself. So that's why control is one of the main primitives in agentic systems as well, is because you can always wrap like an agent in a workflow, or like a workflow can be inside and an agent can be in like a workflow body, or you can actually give an agent to actually call a workflow also, right? It actually depends on how you're going to give the control to, right? So another important thing with agents and workflows is evals, right? Or evaluations, or like how do you know whatever that you have done is actually working, right? So there are different ways that people actually do this. They actually have their own. So most of the time, if you look at it, most of these, when there's a new model release, right? When there's a new model release, you will notice that people actually do a lot of all of these graphs and all of these, right? Essentially, they show you a bar chart. Okay, our model performed better than the other model in this particular benchmark. Um, this model performed better at this task than the other model, right? So those are individual, or like, sorry, not individual, but like independent benchmarks that people actually have done, where you would put the model head to head, right? And see under, and it actually does those particular predefined tasks. Now, we know for a fact that whatever the coding agent gives might possibly work is because they have trained the model and they have made that whole environment or that harness to do that very specific thing, right? That's why sometimes you might feel that Claude Code or all of these coding agents, so like GitHub Copilot, might be better, not always, but might be better than you asking those questions on the web platform itself. But there's always sometimes better that the web platform does. If you look at it, most of the time, if you ask Grok or if you ask Claude, it usually searches the web, mostly Claude, mostly Grok, right? It mostly searches the web and then gives you an answer. Even if it's like a programming question, you actually ask Grok. So Grok is basically the X or like Twitter's uh, model, right? If you look at the web platform, you will notice that they always search the web and only give you an answer, right? But if you look at most of the other things, they would use like pre-trained information to actually give it, right? So it really depends on how they have been trained. So how these trainings are being properly monitored, not I wouldn't say monitored, are being properly like evaluated is using like independent evals, right? There are different types of evals that you can actually do, like LLM as a judge. You can actually use another LLM to judge whether this is actually good. You can actually have scorings that to see whether the tool call that has been called is correct for this particular use cases. How many times have the tool call been called, and all of those, right? So evals is mostly important after you do your agent and you want to test whether it's actually good. Think of it as like a machine learning problem. I actually have like a validation test or like a test set that you would actually use to tell if the model is actually performing good. In this case, just to say that if the system that you actually have built is performing the same way as it should, think of it also as like test cases. So we actually have QAs that actually write test cases to see if our web applications, mobile applications are working the way that they should be working, right? Same thing, testing around this is what evals are, right? So if you look at it, now we have discussed all the 6 primitives that kind of you need to understand to actually build agents, right? There's also something that Anthropic released way back in 2024, which is still like coined to be like one of the very good ways of actually building agents or like orchestrating agents in one way or the other. So they have done 7 different workflows or like different agents, ways how you can actually uh, orchestrate like agentic workflows or agentic systems or workflows in general, right? So we look at them one by one, right? One is mostly what we just spoke of is like a single agent itself, which is like an augmented LLM, which basically we giving an agent specific tools that it can actually do, right? It's like an LLM enhanced with like tools for retrieval, memory, and all of those stuff. Another way that we can actually look at it is also something called prompt chaining. That's basically we have multiple LLM calls that actually, sorry, that's actually used to actually get to the final output. For example, you can actually have one LLM that actually decomposes each of the tasks and actually passes it to like other LLMs as well, right? For example, let's assume that you actually want to do like an outline first, then validate the outline if it's good, then you draft it, and then you probably might translate it to something else, right? So prompt chaining is one way of actually doing it. Just keep in mind that this is a sequence of call to the LLM itself to attain a particular output, right? The other thing is something called routing. So the difference between prompt chaining and routing is it's also calling multiple LLMs, but the difference is prompt chaining is sequential, right? Just keep that in mind. Prompt chaining is sequential, so it actually sequentially does things, right? Whereas if you take as routing, routing is basically you do a first call and you actually pass this across uh, multiple different LLMs to do separate other different things, right? And then you would essentially compose all of those outputs together, right? And then do the final output, right? So that's pattern number 3, right? Then pattern number 4 is also something quite similar to routing, but there is no, what do I say, a classification step per se, right? What actually happens is an LLM operates as like delegated work. an input goes to multiple LLMs at one time, or like multiple LLM calls. It could be the same model also. And then we actually have an aggregator that actually aggregates all of these things and actually gives you the final output, right? Then we actually have something called an orchestrator, which basically takes care of planning and all of those stuff, right? And then passes it down to different LLM calls, and then it will actually synthesize the information, actually give it to you, right? This is usually like something called like an orchestrator worker sort of a model, right? Then we actually have another thing called like the evaluate optimization pattern, right? So what happens is you would essentially give an LLM a task to do, then that solution is passed to another LLM. That LLM judges if it's actually good or not, actually goes back and gives it back to the LLM, actually decides when it's actually, so it's basically a critique mode, right? You have another LLM actually saying whether this work is good or not, right? Then you actually have the other one, the autonomous agent, right? It's like any open-ended problem. What happens is the LLM, depending on the environment and the control or the loops that we spoke about before, kind of independently operates and actually completes the task by itself, right? So all of these things that we spoke of right now, like until point number six, is mostly like a code control, right? But if you look at uh, seven, which is basically the autonomous agent side of things, right? So sometimes the most effective way of doing things is just to do the most simplest things that's there, right? Always default to do the simple thing first, and then you can actually orchestrate or write code to make things a bit more better, right? Because sometimes the most sophisticated system can be a single prompt. Sometimes a single prompt is actually not the best, is because the model cannot really handle everything. So you have to actually decompose things, right? So when you're actually doing things, always start with like a single LLM call, see if it can be done. Then move it into like an agent loop, or if not, then do like a multi-agent system when you want it to, right? Um, so the decision actually comes into play is when do you need an agent and not a workflow, is when a workflow is when you actually know that these are the steps that needs to be done to actually achieve this particular objective, opt in for a workflow, right? If you want to know where, so when you would possibly do like an agent is like there needs to be some sort of like decision making that needs to be there. There's no proper rules that you can probably do, and things are a bit more unstructured. Then you can actually opt in for an agent to actually synthesize and do things a bit more autonomous, right? I know I might have bored a lot of people along the way, right? That's totally fine. Is because I wanted to, before I jump into code, actually wanted to introduce all of these concepts first, because whatever the concepts that I'm presenting right now is very canonical or will be used across any agent framework that you'll be using. So I'm happy that if you already know this already, so you might find it very boring, or there might be cases that people really don't understand what this is. You can ask questions if you want, or you can actually take these keywords uh, and do the searching that you guys want, or find like in the middle layer of the bell curve. I hope you guys are all following along in terms of how this can be used to actually do the thing that we'll be actually doing as a demo, right? Um, okay, since I have actually introduced most of the concepts that I actually want to do. I just want to tell you that I want this to be like a hard stop for to ask any questions. If you have, I'll probably just keep like um 30 seconds for this. I'm usually not used to talking very slow. This is probably the very first talk that I'm doing very slowly. Um, so probably might be boring, so I kind of understand as well. From moving forward from here, I'll be a bit more faster. So if you have any questions, you can ask me. I'll open the floor for like 30 seconds. Okay. Seems that there are no questions, so I'm going to speed things up a bit more, right? Um, okay. So this is our middle point. Moving forward, everything around this would be on the demo itself, right? I'll be introducing to you on how the demo is being structured, and then I'll be actually talking a bit more, and then actually share you the code, and you guys could actually take it from there, right? Anything from here is not very, anything after this is very Mastra or like the agent framework that we're using, very specific. Everything that I've covered before is basically basic primitives or keywords that you should be knowing, and also on how you can actually orchestrate the different systems, right? So just keep that in mind. Whatever the primitives that I have used is the same keywords that's used in Mastra. And also the 7 patterns that I've actually kind of shown you are also being used here. Not everything, some, right? Because not every pattern fits every use case, right? So like I said before, right? We are essentially going to be doing like a issue triaging agent, which basically tells or like classifies um, different issues that are given. I'm not connected, just a bit of a this thing. I'm not connecting this to GitHub. I actually have like a very fake issue list that I have done. So you can always connect it to GitHub the moment that you actually want it to. It's just one tool change, right? But I've also made like a small coding agent, so you can actually take that particular issue and actually solve the problem also, right? So we'll be actually looking at this in like 4 separate stages. One, we'll be actually doing like a single agent. Then we'll be actually converting that into a workflow. Then we'll be actually doing something called like an agentic workflow. And then we'll be actually doing like a supervised agent where you talk to one agent. It actually has other sub agents that would basically do the thing also, right? Okay, so there is a question around the best free LLMs that we can use. I'll come back to that. I do have a not a slide, but I do have like a note on that. So I'll actually touch upon that as well. And also don't call me sir. I hate to be called sir. Unless otherwise you're in the class that I'm teaching, don't call me sir. Um, okay. So if you look at Mastra, right? Um, Let me actually, before I actually do these slides, let me actually give you a bit of an understanding around Mastra. Or let me actually do this. I'll go in the same order that I wanted to go, right? Um, what we'll be doing is stage one is we are going to have one model and one tool, or like a couple of tools that you can actually use to actually answer questions, right? So if you look at it, this agent, what it does, it actually classifies and labels issue, right? And it has the tool to actually get the issue and add the labels as well, right? Stage two is actually going to be something sort of like an approval stage, right? For an example, it fetches the issue, classifies the issue, plans the label, and actually asks whether this is the right issue that I want to do, and then it actually applies this. Why this workflow is a bit something that you should keep a note of is it actually looks at something called HTLS, which is human in the loop, right? Which is one sort of a pattern where you might see that ChatGPT or probably when your Cloud Code or whatever it is actually asking you permissions whether it should do this or not, right? So in that workflows are essentially a better way is because you can also resume and suspend workflows based on approvals as well, right? Um, so if you want something that's replayable, suspendable, workflows are ideally the best thing. Then we are doing stage three, right? Which is basically an agent which actually has workflows. So an agent can actually call the specific workflows itself, right? Then there's stage four, right? Which is 3 specialized agents. Actually, I forgot to update the slides. But there are 4 specialized agents, each doing its own uh, specific thing. But there's one supervised agent or like that one main agent that actually delegates these works for this, right? So these are the 4 different types of patterns that we are going to be going for, right? So that's what I said. Whatever that I've told you before is how we are going to be doing things. I was trying to go very slow on that. now since everyone knows these terminologies, I'm doing a bit more faster, right? So depending on the choice of your particular pattern that you're choosing, right? Uh, you can see different costs, right? So these token values, sorry, I should have been a bit more specific. So these token values are basically the usages that actually has been happening, right? So I got Claude to run this and try to understand what are the token usages it actually took from Astra and document that as well, right? So you probably might, so you can clearly see that when you do like a very single stage LLM, right? Its tokens are very less. So tokens equate to how much the LLM is going to cost and all of those, right? If you do a workflow, it might cost a bit more. If you're doing like an agentic workflow, it might cost a bit more. Supervised agent probably is the most expensive thing that's there, right? So if you look at it, it's the same six primitives that we've been talking about, how they have been different, that they've been wired differently, dependent, right? And then they actually have different costs as well. And one thing to remember is don't expect all three of this, or at least all four of this to work the same way, right? You might observe different behavior, is because inherently LLMs are non-deterministic. What that essentially means is it might tell you one thing now, it might tell you another thing later, right? So keep that in mind. So so right now, before you even work with this tool called Mastra, I'll actually share you I'll share you a link to Mastra. While I'm talking through this, you guys can possibly um, go through Mastra's documentation or like understand what Mastra is, right? I'm putting this on chat, right? You guys can go into the docs while I'm talking all of those stuff if you want to, right? So Mastra is like an agent framework itself, right? It's mostly TypeScript based. Essentially, it's TypeScript based, right? It's basically a framework for you to actually build AI-powered applications or agents itself, right? Um, why Mastra is because it actually has a lot of things out of the box, from RAG to observability to workflows to memory to tooling to RAG to everything, right? It actually has everything built in. It's a like like every framework, it has its batteries included, right? It actually has everything. But Mastra under the hood is actually run by something called the AI SDK, like the Versal AI SDK. The Versal AI SDK is basically a set of primitives that is being done to call LLM or like different models, right? Orchestrate tool calls, orchestrate loops and all of those stuff, right? So it just has one shape, one tooling shape, and it has swappable providers, right? And the ecosystem of it is very large, right? Hold on, I don't know what happened. Okay. So essentially, it's an abstraction layer on top of how you can call models, right? So Musta is actually built on top of it. Most of the agentic frameworks right now are actually built on top of it, from multi-agents. So if you look at most of even Google's ADK actually has like a port that you can actually port to AI SDK if you want to, right? Even Google ADK. So essentially, it has three abstractions, right? Generate text, stream text, generate object. Generate object, I think they deprecated also. Then you actually have UI frameworks for it, like UI SDKs for it as well. So let's say you want to build something like ChatGPT, you can do it. They have hooks for like use chat, use completion, and all of those. I'm not building like a UI layer on top of this, so that's something that I won't be touching. So there are provide abstractions. So if you want to go from OpenAI to Anthropic or anything else, right? It's just you have to go ahead and change the SDK of where you're calling it from, right? Then tool calling is actually handled behind the scenes. So it actually takes Zod schema. So it actually takes the schema, converts it to JSON schema, sends it to the LLM. when the LLM decides, okay, this is the tool that needs to be called, it actually handles that as well, right? It has these stop conditions and all of those stuff, right? So Mustra is because of the AI SDK, but Mustra is not vanilla AI SDK. They just use AI SDK as a wrapper. And they have a lot of other primitives that actually built upon it, right? I've been using Mustra for probably close to 2 years now, and I love the way that they work and the things that they ship as well. Okay, that out of the scene. So things that you should remember is models, prompts, tools, and essentially, if you want to add a stop condition, you can add a stop condition, right? Master is a layer. Just keep in mind, master is a layer. It's not a replacement per se, right? Um, Sorry, AI SDK is a layer on top of master. It's not like a replacement. You can, if you don't want to get into the entire thing of building your own agent, if you don't want to use like the agent framework like Mastra, you can actually use an abstraction called the tool loop agent that AI SDK gives you. It's essentially like the agent primitive like Mastra has. Same thing is what the tool loop agent is, right? So talking about Mastra is like a framework to build AI-powered application. Sits on top of like the Vercel AI SDK. It's its core is like the AI SDK itself, but actually builds a lot of other primitives that's there, right? So Mastra comes a lot with like a lot of bundle packages. One of that is like the Mastra core, which is what we'll be predominantly using. We have memory, which actually has adapters, whether you want to save the memory to Postgres, you want to save it to Redis, so all of those stuff. Then it actually has like different stores, a lot of loggers. It has the CLI. It also has like the vector DBs and vector or like the RAG pipelines on either like PG Vector, Pimeco, and Chroma, libsql, and all of those, right? Apart from what these packages is like Master actually adds a lot of other things as well. It actually handles observability. It actually has something called the Studio. It has its own MCP servers. You can use MCP servers. You can deploy. It has its own deployment service and all of those. So Master is an built package, so like an entire framework that actually has everything that you actually need, and you can actually build things on top of it. For an example, I'm building like open claw sort of stuff on like Mustra. I'm using AI SDK to actually do custom harnesses and all of those stuff, right? So it's a bit more extensible by default, right? So if you look at the structure of like an agent from Mustra, is essentially it's like an agent, and then you have the tooling. Essentially that I just noticed that the slides have gone down. I actually show it by code, right? And you have the registry, right? If you look at the workflows are composed of like very individual steps, right? Steps can be of multiple things, right? And then you can either chain things or you can actually branch things, right? I'm going to come back to these slides again, so don't worry. I'm just skimming through this just to show you the syntax first, and then we'll actually come back to this again, right? Um, so whatever that we've spoken so far, right? Like the primitives, right? So we spoke about models, tools, control, loops, memories, right? Everything is like baked into master. That's why I actually wanted to do that. Every framework right now actually has that, right? So it's nothing to I think, but it's very developer friendly. So to answer that question around what are the best, I don't think the person is here, but I don't know. But essentially, just to answer like what are the best LLMs that you can probably use for free, it actually totally depends, right? We are going to be using something called Open Router, right? Open Router is like a gateway, right? Open Router is basically like an AI gateway, which actually gives you a unified API across different models, right? If you go into the models page of it, you can actually see that it actually has a lot of models that you can actually use. right? You can actually, this actually has free models as well. So I think if you search for like free, you'll notice that if this has the tag called free, you can actually use these for free if you want, right? These are very good models. NVIDIA Nematron is apparently good. The Minimax, I can personally vouch for that this is good, right? So if you want to try out free models, I think you can try the Open Router. You have to create an account in Open Router and just use these models if you want, right? I think if you do Hugging Face, if you have like an Hugging Face account also, you can actually use free models when you want to. So depends on what you call free. There are providers that actually give you free stuff, but in terms of models, Nematron is good, GLM 5.1 is good, um, Kimi is good, and all of those, right? Um, Dependent on in the different use cases. If you still are looking at like free providers, you can also look at something like Grok or Cerebras. Uh, they give you Quen and all of those stuff also, right? Um, Grok actually has Llama. I forgot the models that they give. I used Quen from them, but I took it down, I guess, recently. But anyway, they have Llama, they have the GPT OS you can use, but their Llama models are good. Okay, they still have the Quen model here. If you go to Cerebras also, Cerebras is also decently free tier, right? They actually have Llama 1.3.8. They have GLM that you can use, right? Uh, Things like that. But you have to know that these are very limited stuff. They're not always giving you the full power, but you can potentially use them to trial things out, right? So we'll be using OpenRouter. The main reason I actually chose OpenRouter is you guys can try these free models, but I'm going to be actually using Claude, just so the demo doesn't break. Uh, but yeah, okay. So core primitives that you need to, I'm introducing you the syntax before we go deep into the code is because I actually want you guys to understand what Mastra is, right? Then I'll show you the demo, then I'll actually show you the code, right? Okay, let's take a pause from here, right? I have a couple of more other slides, but those slides are essentially future stuff. So what I'm going to do is I'm going to bring up the code, right? Let me know if you guys can actually see my cursor, like I mean the VS Code for cursor. So yeah, you guys can actually follow along. There is a QR code that you can potentially scan. I'll keep this up, or you can actually go into this. I'll put this on chat, guys, chat. If you go to that repo, sent on chat, you have the triage bot. You can run through the code with me, right? I will upload the slides also to this. But essentially, this is like a project that's actually been done on Mastra. So what I'll do is actually run you through the studio first, then actually run you through how you can actually, you don't actually have to use the studio, you can actually run these by code and all of those as well, right? Okay. So coming back into this, I have actually run the master studio, right? I'll show the demo first and then I'll actually go ahead and run through the code, right? So if you do master studio, right? Master studio is basically the interface of the master's dev environment. Uh, Essentially, it actually gives you a UI on top of the code that you have written, right? It on the sides, it actually has workflows, agents, workflows, the MCP tools that you have registered or the tools that you have written, and all of those stuff, right? Then you actually have workspaces. I'll actually come back into workspaces also. Workspaces is a pretty new feature, but something that I'll actually show you. Then you have traces, you have matrices, and all of those stuff, logs, whatever that happens, right? Okay. Storage is not supported. I'm going to close this, but I have a fresh run. I didn't configure traces, so I'm not surprised it broke. Okay, so I have actually configured. Okay, good. Okay, so I've actually configured a couple of agents, right? And I've actually configured like a demo agent also, right? So I'm using the Gemini Flash model for this. For all the others, I'm using the Sonnet model. The main reason is this is cheaper than Sonnet, so I assume that we can do it like this. So I'll run you through the demo agent first, right? So the demo agent is basically your entire guide in terms of how to run this particular repo, right? I made this agent just to specifically show workspaces and MCP servers and all of those stuff, right? For example, if I ask um, how how do I run this project, right? Now, what's actually going to happen is actually going to understand what are the files in this, right? Read the files, understand what is actually there, and then potentially give me an answer, right? Okay, something is wrong. Then this worked before I came. This is why all systems are very non-deterministic. Okay, I think possibly it's because let me quickly check this legend. Okay, until that probably fixes itself out. Let's see if the demo is in work. Okay, think something to do with the workspace. We'll come back to that. I'll actually go ahead and show you all the other agents, right? So you actually have a couple of other agents, right? If I go into one of these agents, if you look at the studio actually gives you a UI that you can actually play around with. Um, all of this stuff gets activated when you actually add like observability, but by default, what actually happens is you're looking at right now is like an agentic triage. This agent actually has tools like get issue, search issue, add labels, post comment, close issues, and all of those stuff, right? So we give it a system from saying that you're an agentic GitHub issue triage bot with full agency over the tools that you can use, right? So we'll actually ask can what can you do? So it says it tells you what it is, right? Can you what issues are open, right? So what happens right now is it actually would essentially okay, okay. Get first search for bug. So what happens right now is actually using the search tools, it finds the things from that particular listing, tells me that these are the issues that I have and all of those, right? Um, can you close the first issue? Can you close issue 5? Right? So issue 5 right now is open. So what we're doing is we're actually asking it to close issue 5. Okay. Um, so that's okay, sorry. Sure. Okay, I moved, so it didn't actually do it. But essentially, these are the different of the agents that's there. The other one is something called like the supervisor agent, right? Um, what are the issues we have, right? So it's listing all the issues right now. Why this can actually list all the issues is because we actually have a tool called get issues. Uh, get the fifth issue, right? Uh, if you ask it to get the fifth issue, it'll actually go ahead and get the fifth issue, right? Okay. Then for an example, let's assume that I can you fix issue 2, right? Let's look at the tool calls, what's actually happening, right? So it's saying I will triage 2 first. First, I'll actually understand what's actually happening. It tries to get the issue. It classifies the issue, right? It runs this classification, this thing, right? Then it searches the issue. It finds that this is the issue that it should be targeting and all of those stuff, right? Yes, code the solution, right? I know this really doesn't make a lot of sense to this thing, but I'll actually show you what's actually happening, right? So this is like a supervisor agent that actually has different tools. It's actually calling, right? Now the code agent actually has like the workspace. It's going through the workspace. Now it's actually creating the source folder. Now it's actually writing this, right? For example, this workspace is actually here, right? So it's actually going ahead, creating all of those files, right? It has replaced this user, blah, blah, blah. Okay. So while that actually happens, let's actually go ahead and see how all of this is actually done, right? Um, I'll start off. So you will notice it's actually keeping on going, right? So it's actually saying that the issue has been fixed. So it's actually not going to go ahead and go forward with it, right? Things like that. All of this is essentially the supervised agent that I'll be showing, right? None, all of this is very, very, very straightforward things. Whatever that I actually showed you right now is essentially this, right? Okay. Building agents right now is very, comparatively very easy, right? And the moment that you actually realize it's easy, you will realize it's not. Okay. So what we're doing right now is we're actually defining something called an agent. We're using Mustra's agent primitive. We are giving it an ID, we're giving it a name, and we're giving it a set of instructions, right? So the instructions is very important. By default, this is what actually gives an agent, right? A voice, gives it the anonymous, like the anonymous function that it actually needs. Sorry, autonomous functions that it actually needs. It tells it what it should be doing, and all of those stuff. It also gives it a role on what it should be doing as well, right? Then we're using the model, we give it a model. We are using the, what do I say? We're using Sonnet, using Open Router, right? We are giving it a list of tools. We are giving it a couple of agents, and then we are actually giving it a bit of memory, right? So keep that in mind. So all of this can be seen here, right? Okay. Now let's work backwards. Now we saw a demo around the supervisor agent. So you'll notice that the workspace has actually worked here also. I'm not too sure why it failed before. But let's actually work backwards, right? Now this is the instruction that we have given it, right? I'm going to close everything else. Okay. Code is with you guys. You can actually go through it. I'm not going to read through the system prompt, right? But the important things are actually what we give the agent is the tools. Let's actually go ahead and look at the tools, right? So the tools, I have actually done this inside a folder called tools. Inside that, I've actually given something called github.ts, right? The most important thing that you actually really need to understand is when you're creating the tool, you're supposed to give the schema, right? You have to give a proper description, right? Because the description is what the agent uses to call this particular tool, right? Um, so when I say search a tool, what it essentially is like searches an issue, it realizes, okay, there is a tool called search that I should be using. How it actually knows that is because of these descriptions, right? So keep that in mind, right? So let's actually look at one of these tools. Let's say a tool called list issue, right? So if you look at the list issue tool, right? That's what we are coming from, right? List issues. We look at list issues. It's basically something called a create tool. This create tool is actually coming from like master tools, right? If you look at the source code internally, it's a bigger, more function, right? You give it a description, right? Sorry, right? So you were here, sorry. So it's a bit of a, you give a description. The description has to be very verbose, saying return a condensed list of every issue in the backlog, number, title, author, label, state, without the bodies. Use when the user asks about a backlog or a whole list of issues that it actually wants, right? For full content of one specific issue, use the get issue instead, right? So if you go back, what are the issues that you actually have? It actually called the list of issues, and you'll notice it actually returned what I actually asked it to return, right? Why is because in the output schema, I have also mentioned that these are things that actually should return, right? And the execute function is what happens when a tool is called, right? So you might be wondering where is this issue is coming from, right? The issue is actually a hard-coded list of issues that I have done. But you can always replace this with a DB call. You can always replace this with like an external API if you want, right? So that's tools, right? Then we'll actually look at what it called next. When I actually asked it to get me the fifth issue, I made a mistake, like fifth issue. I don't know how I made a spelling mistake. I asked it to get the fifth issue. It actually went ahead and got me the fifth issue. And it actually used the tool called get issue, right? If I look into this, the supervisor already has a tool called get issue. So I'll go into the get issue tool, right? Get issue. So it says fetch a single issue by the number from in-memory store, right? So why the tool called is actually asked for the fifth issue, right? So it returns the issue, right, to me. Okay, it returns the issue to me. That JSON, whatever was written, like was returned by the tool, it actually synthesized its own information. So when I actually asked it to fix this particular issue, right? Can you fix issue two, right? Uh, when I actually asked it to fix issue two, right? What I actually went ahead and actually did was it tried to understand what issue two is, right? Remember, we have been asking about issue 5. We never asked for issue 2. So issue 2 is not in memory, right? So it knew that, okay, it has to get issue 2 first. It needs to classify what issue 2 is, right? Then it says, okay, this is a bug. No code fix yet. Should we fix it? Right? So when I asked it to fix it, right, it actually called the code agent. The code agent actually wrote specific code that you can actually find here, right? Uh, to go ahead and actually fix these stuff, right? So keep that in mind. Okay. Now let's go into each of these calls, right? Why I'm working backwards is because you understand why it actually decided to call all of this, right? So now it says, can you fix this issue? Right? Now, when I said, can you fix this issue, right? What actually happens is actually reads the system call, right? So you'll realize that I'm saying that you are an engineering manager, which has a lot of agents, right? So it has decided for it to actually first fix issue 2, it needs to get the issue, understand what the issue is, and it needs to triage. Remember that this is actually a triaging agent, right? So it actually calls this agent called triage classifier, right? So if you look at it, the agent triage classifier is a read-only IC, which is like an individual contributor that classifies the issue, identify duplicates, detects the repos, and returns all of this stuff, right? So essentially, what it decided, it really needs to understand this issue. They actually called the triage classify agent, right? Let's go into that agent, right? So the triage classify agent is basically, right, an agent that reads the GitHub issues, has two calls, like two tools, classifies the things, right, and returns only a summary, right? So what happened is actually gave it a summary of things, right? This is its output, okay? The agent used its tools to actually classify the issue, and it's telling, okay, this is the issue that's there. It's a bug. Do you want me to fix it? Right? Then what actually happens is when I actually asked it to code the solution, then it actually calls the code agent, right? The code agent itself is another big agent, right? Is working with workspaces, right? Why workspaces? Is because inside the workspace, you can actually give it, right, a sandbox as well as a file system to work with. And because Mastra Workspaces actually has tools that call read file, write file, edit file, understand these codes, right? This is all that you need to actually write a coding agent, right? It's a very simple coding agent, right? This entire workspace, right? This entire workspace is hiding a lot of the tools that it actually has, right? So when I actually asked it to start coding, it listed all the files, right? So there is no files. So these files are there, right? So if you look at the server files that it had created, you'll notice that it actually created all of these files, right? Going back, right? So what it actually did was actually went ahead, listed everything. At first, it felt that there was actually nothing inside that, right? There was nothing there, right? It says zero directory, zero files. Then it actually made a directory called src, right? That's what you see here, right? So if you go into this workspace, you will see it actually created something called src, right? Then it wrote to file, it created a thing called src user.txt, that's this file, right? Okay, and it wrote this content, right? It wrote this content inside here, okay? Then it decided, okay, it needs to do the server.txt also. It went ahead and created the server.txt also, right? Okay. And then it had to create the file, it can edit files and all of those stuff. Okay. So if you look at it, it did its entirely its own thing, right? It had the right tools, it had the right environment to do it, and it had the right context to do it. Okay. This goes back to our 7 primitives. Okay. 6 primitives. Sorry. So the point that I'm trying to make here is the fact that sometimes building something is all about you using the right tool, right? I could have gone ahead and given a tool for it to actually write file, read file, and all of those stuff. But I know for a fact that master actually has these workspaces primitive, right? These workspaces primitive, right, actually has a lot of things that you can actually use, right? So these toolings that's there is actually built into it, right? Because these toolings are built into it, actually, I can actually use it in a way that it can write files, read files, and all of those stuff. Okay. So this entire supervised agent, right? It took an issue, used the right tools to do it, right? And got the job done, right? And 70% of this is giving it the right tool and giving it the right prompts, right? Your prompting is important and your tooling is very important because right now all agent framework can handle a lot more things, right? So this is how autonomously it actually call things, right? Now, if you look at all of these agents individually, it can do it if you want to, right? For example, if I go to this coding agent and say, create hello world JavaScript file hello demo.tsx, right? So right now it went ahead and created that for me, right? And where can I go ahead and see this? Is inside the workspaces, right? Okay. So it actually created the hello demo.tsx for me. Okay. So this is inside, since it's inside the sandbox. If I remove the sandbox, then the files would disappear. But right now, since I actually have a sandbox in place, very scoped out environment, it can actually go ahead and do it. So you can actually use this agent individually also, right? Then let's actually go to workflows, right? So we actually have this workflow called triage agent, right? So I'm going to go ahead and pick the very first agent, very first issue number, right? So it did one specific thing. It fetched the workflow, it classified it, it planned the labels, and it's asking for my approval, right? I'm going to go ahead and approve this and resume the workflow, right? Now this workflow is complete, right? So if you look at each of these runs, you will notice that the issue number one is it doesn't work. This is classified as need info, where it doesn't lack enough quality information. It plans the label, right? The label is like this thing, and it waits for my approval. Once I approved, it actually applies the different tools that's there. Now let's actually look at this workflow, right? Workflows are longer codes, right? Is because if you look at the control that we spoke of, control is given to the code itself. So orchestration is not very autonomous. We are the ones who are actually writing this code that this workflow has to be called, right? So let's actually go one by one. So we are calling this triage workflow, right? We are creating a workflow. Remember, create workflow primitive is actually from Astra itself, right? So we are giving it a description, deterministic DAG that fetches, classifies, uh, plans, labels, and approves and applies, right? So we have an input schema. The input schema is an issue number. That's what you actually saw here, right? Issue number, right? And the output schema is the applied label, the final state, the kind, and the reason, right? That's what we got here, right? Let's go step by step. In a workflow, there needs to be steps. Let's go to the first step. We are basically saying fetch the issue first, then classify it, then plan it, then approve it, like wait for my approval, and then mutate it. Let's go to step one, fetch issue step. So in the first fetch issue step, what we're essentially doing is we are getting the issue. That's it, and we're returning the issue, right? Then we're actually classifying the step. Okay, we are using a generate object. You don't need to use master primitives always. You can always use Versal AISTK primitives itself, right? And return the object. We're basically giving this a prompt. So this is like a single LLM call. So this doesn't really need an agent. So we're using AISTK's generate object. It's basically deprecated right now, but you can use it, right? Essentially, we are giving it a schema, right? Uh, so this generate object falls under the concept of structured output. Structured output is you're basically telling an LLM, I need this particular JSON schema format, right? So I'm giving it the model. I'm actually giving it a schema saying that this is the schema that I want. I need the kind and the reason, right? And I'm giving it a system prompt saying that you're a precise GitHub issue triage classifier, read the title and classify at least exactly one category, right? Be concise in your reason, right? In that particular step, right? Classify step, right? This is what actually happened, right? This is the output that we got, right? If you look at the input, right? This is the input that we gave it, right? This is the output that we got, okay? And this matches the exact schema that we gave, right? And this is like an LLM call, right? So what I'm trying to tell you is you can actually have LLM calls or any calls inside a workflow also, right? Because you're the one who's actually doing the same thing as you giving it a tool, right? Then we have the plan thing, which actually plans what kind it is and all of those, right? So one thing about this plan step is we are getting past results, right? We're actually getting a past result. So in Mastra, it's a workflow, like it's a graph, right? You can always go back behind node, right? And how you can get that is using something called the get step result. We are getting the fetch issues. This is no promise. We are getting the fetch issue steps result. What is fetch issue steps result? Is the output that this is there, right? Then what's actually happening is we are getting it, we are planning on how things should be doing, and we are sending the kind, we are sending the reasoning. This is like an intermediate step, right? It's like an intermediate step. Then we actually have the suspense, resume, and all of those stuff. This is basically primitives inside Mustra for human in the loop, right? We are suspending the workflow until an approval is given, right? And then we do the classification and then we apply, right? So remember, this is exactly the same thing the supervised agent did, but we have done it with the web, right? But if you look at this triage agent, right? Right, this triage agent workflow is same thing that we can actually instruct an agent to do the exact same thing also, right? We don't really need to do a workflow for this. You could have done it in agent also, but remember that you wouldn't have this human in the loop approach, right? That's something to remember, right? So you can always give an agent some workflows also. Like for an example, I can actually give the supervisor agent a set of workflows, and I can actually ask it to go ahead and actually use this workflow also. Then I can go ahead and actually update the system prompt saying, hey, if you want to triage something, go ahead and use this workflow also, right? So I can give an agent a set of tools. I can give it sub agents, and I can also give it workflows. keep in mind that this syntax is very small is because of the master primitives. If you're hand rolling this by yourself, then there's a lot of things that you have to be doing, right? But just understand that some frameworks actually make your life a bit more easier, right? Okay, that's that. So right now, what I kind of have showed you is how you can create your own individual agents, how you can actually give agents a set of agents to work, and how you can actually do workflows, right? Another thing to remember is any call that I'm actually, let's see if this got fixed. What is master? Okay. Essentially, I'm just asking what is master. So what happened is I gave a set of tools, right, to this particular agent to understand and know what master is, right? It also has some workflows, workspaces. I'm not too sure why this workspace might break. Uh, but let me just go ahead and see what files we have. I will enable memory so every time it disappears. Anyways, so I just gave you a set of tools, right? So what is master, right? What is master and what tools are we using in our project, right? Let's let that go, right? Until that goes, I'll actually show you this demo agent, right? So this demo agent is very, 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 very small, right? There's nothing too much to it. I just realized why it might break this part. It's not this. Um, Essentially, the only different thing that we're doing is we are defining tools as an MCP, right? We're giving it a workspace. We're also giving it like an MCP. MCP is something that you probably might hear a lot along the way, right? MCP is like Model Context Protocol. It's basically a way for you to actually expose your external systems to this to an agent, right? It's one way of doing it, right? Either it can be an HTTP REST point or it can be uh, a CLI tool that's there, right? For an example, this master client or this tool is actually coming from master docs, right? So master docs uh, is master MCP docs, right? Sorry about that. But essentially, if you look at it, master out of the box supports like MCPs. MCPs are model context protocol. These are standards that were created by Anthropic that allows different AI agents to actually connect to this. So, for example, if you look at this, you can have a protocol that actually allows you to connect to databases, development servers, any other productivity tools that's there, right? Uh, why this is actually important is because this is one way that you can actually connect different other systems to this, right? So if you've seen like OpenClaw and all of those stuff, those are basically connecting through MCP servers and all of those stuff using like Google Calendar, Notion, and all of those stuff that comes in. You might also sometimes see that people are actually using like Figma designs and all of those stuff. How they create this using Claude Code is because most of these people actually expose MCP servers, right? One of those MCP servers is what the Mastra documentation is, Mastra docs MCP server, right? The Mastra docs MCP server is basically um, how they're actually doing this is they actually give out their docs inside a particular tool, right? Where any MCP client can actually connect to it and understand what's actually happening, right? So if you go inside this particular this thing, right? Mastra MCP doc server. I think it should have been installed inside this. Sorry, no, modules, doc server. So if you look at inside this doc server, right? It has different toolings for you to actually go ahead and do things, but the entire docs is inside this, right? So Mastra's entire documentation is inside this, right? So what happens when you connect this particular tool, right? When you connect this particular demo MCP, sorry, when you connect this to the MCP, there are specific code like the JS code that's there that actually sends or searches through this, right? So for example, let's assume that someone is searching. Okay, when you're actually searching through it, let's say like add like evals or write test cases, what actually happens is there's a bit of a tooling that actually happens, exposes the docs to this agent. So the agent actually uses these tools, right? The agent actually uses these tools to actually understand what's there. So it actually reads this full documentation and gives you an answer, right? That's what I actually wanted to show as well. You can actually have like a lot of other MCP servers to actually or have connect this tool agents to different applications using MCP tools, right? People are opting away from MCP and started using CLI tools and whatnot. There's this nice service called Composio, right? Composio, what they give is they give enough toolings for you to actually connect to different systems, right? You can connect to Slack, you can connect to GitHub, you can connect to GitHub, sorry, you can connect to Salesforce, all of those stuff, right? If you search for Composio MCPs, right? You will notice the different toolings that they actually provide you, right? Or different tools that actually provide you to connect it, right? So I can have an agent that actually connects to GitHub, right? Or goes through my calendar. If I have to email someone, I can ask it to use this particular tools to actually go ahead and do these things, right? So just keep that in mind. You don't only have to author tools, you can always use other toolings that people have provided in your agents as well, either as an MCP or as like a CLI tool if you want, right? Okay, that's mostly it on the things that I actually wanted to show you, right? I'm going to close this. Right? There is this inside the GitHub that I showed you. There's actually something called like run demo runbook. You can actually read through it and run through the demo yourselves. But one thing that I actually wanted to show you is that even though they actually showed you all of this through the CA, like the Mastra Studio, right? You can actually use this directly in your CLI, in your backend, and all of those stuff as well. One thing about Mastra uh, is that it can be used in like different frameworks, right? So that's something that I love about the fact also because it's a JS framework, you can connect this to an XJS project. You can call it in like an XJS API if you want to build UIs on top of it using the AI SDK and all of those stuff. There is support for like Copilot Kit, Assistant UI. These are very, very good toolings around this. And if you look at it, Vercel actually released something called the Vercel AI Elements, right? If you're familiar with like, sorry, if you're very familiar with Shutzi and Tailwind and all of those stuff, There are components that have been given by Versal that you can actually go ahead and build these very beautiful UIs on top of Shadsi and with all of these connected properly. Um, if you want to set it up, you can set it up, and then you can actually use the AI SDKs, AI SDK UI. They have a primitive called the use chat, right? You just have to point, you have just to create your UI, sorry, you have to create your router, and you can actually point your master agent to that particular route. And it should work the same way as the same Master Studio works, right? So for an example, if I go ahead and run this, right, I'll run this again. If I just go to, I think it was called API, right? Uh, if I go to API, okay, okay, sorry. If I do API, you actually get like a full list of routes that you can actually connect this to, right? You can call workspaces independent, workflows independently, call files in workspaces. You can embed things, you can call agents. All of these APIs are actually pre-built into it, so you can actually build your own UI around this. So for an example, one of the recent projects that we did is we made like a social media. This is a client project, not an internal project. We made like a social media analyzer tool, which actually scrapes information from your social media, understands your posts, have different agents rate that, and then give you a final verdict, right? That was like a custom UI that we built on top of the APIs using the master API itself. So that was a complete workflow, but it actually had agents that actually powered each of these workflow steps and all of those, right? So if you're interested in building your own UI, you can always use the master API. There are good tooling around this to build your own agentic UIs. Copilot Kit is something that's coming up a lot recently, but you can always hand roll your own UI. Anyway, so that's second way of interacting with the master agent, right? Or your agents. Just keep in mind it's the same thing for LangGraph, LangChain, Deep Research, Agno. All of these frameworks that are there actually give you same thing, right? Either an API or like a studio, or either like to work with essentially uh, your agent, right? So for an example, let's assume that I actually want to run the very first agent. I'll just go ahead and run this, right? So it's actually reading through the issue and all of those stuff. So how this actually works is actually made like a very small um, CLI tool, right? If you go inside package.json, you will actually find there is this script that says triage, which runs the CLI. Essentially, if you go inside the CLI script, what I'm basically doing is I'm actually getting these agents, right? I'm calling this agent, right? And I'm just invoking this agent, right? So how you can actually invoke this agent is you can actually use master. So the most important thing that I actually forgot, I've been showing everything, but I didn't show the registry, which I showed missed earlier. So the master UI that you see is because of this registry that we have kept, right? So we have kept what are the agents that are there, what are the workflows that's there, what are the storage, and all of those stuff, right? So just keep that in mind, okay? Um, okay. Then this is how you would add memory, like you can have memory turned on, you can have logging and all of those stuff. Anyway, coming back into the CLI, the very first agent, right? So you can actually call the master registry, what we have defined here, right? And then you can actually get the agent by the name, right? The agent by the name is, we have called it triage, right? So we call it triage with the triage agent, and then we just call generate, right? So what we are basically saying is when this is called, this is the prompt that we are giving. right, to this particular agent. Triage the issue with the number. So if you look at the thing that I actually gave it, I said triage issue two, like stage, which is agent one, right? Agent one is basically like for information, but essentially what it's doing is actually triaging the issue. It's finding out the issue. It's calling the tool, right? The tool is being called. It gets the results and it gives you a response, right? So this is how you can call an agent by using the CLI if you want to, using master, right? Since we are doing a generate, it's a stream. Since we are not streaming, it becomes like one particular thing. So you can actually go through the results and loop through them. Again, I not something that I actually want to show in detail is because this is basically essentially this is all you need to actually call the agent. But the rest of the code is for me to get the logs, right? Everything else is just logs. That's okay. Um, so you can run through the code, but my main motive is to be very framework agnostic as possible. That's why I actually didn't go into a lot of Mastra implementations a lot, but rather told how agents can be created. This new agent is basically if you just go into LangGraph itself, right? Um, if you go into the agent docs of LangGraph, I know this is Python, right? But essentially they actually have something called create agent, right? You give the model, you give the tool. Then you have their graph model that you would go ahead and do. But essentially, that this is a bit of a more clean abstraction around the agent primitives, right? Even if you go to Agno, right? Agno agents or even Pydantic agents, if you are still going to be like Python, um, finding the right correct block. Okay, so you will notice that this is the same agent primitive that you'll be giving output schema, system prompts. Even if you go into like Agno create, right? Building agents, you will notice it's just the agent primitives, the model, tools, instructions, and all of those, right? The main idea that I actually want to convey through this is not Mustra, but Mustra is a good framework to use, but rather that most of the people follow the same primitives that's there. So always you give the instructions, you give it the tooling, and how you give control is going to be either through workflows or using agents. Again, this this entire session is about giving you the right keywords, right primitives that you should be knowing to actually adopt it across things. Because one thing that I've noticed, at least on a personal note, if you know a lot of things or if you know things, it's easier for you to find information and it's easier for you to prompt the agent to actually do the work that you want to do, right? For an example, if you ask, if you give the MCP like Claude code, the Claude, like the master docs ask it to create a supervised agent. I want all of these agents with the system prompt. So like you just give it like a baseline system prompt. Um, I'll go ahead and create it, right? Like code right now is cheap. It's always about execution. And execution actually comes from you understanding what is around there and the concepts that's there. Otherwise, you're just believing whatever the agent is telling you, right? Or the LLM is actually telling you. Okay, that's a bit around how you can. So as of now, what we have covered is like basic first principles on what are the primitives that's there, how you can orchestrate um, like create. I wouldn't call it create, but rather how what are the different wirings plus orchestrations plus different methods of you creating agentic tools is there, right? Then we spoke about how you can create all of this using some like the master framework, how tools control, how all of this entire hexagon comes into play, right? All these primitives, whatever that we have learned so far, how it can be done in code, right? Now, let's actually look before closing. I want to also touch upon where things are moving, also, probably as of now, because a lot actually has happened in the last 3 months. A lot after Claude started going more commercial users, open claw becoming a lot of things, people right now are actually aware of things, right? So those days they said that, like, even to date I still agree with this. They used to say that, like, prompting is everything, right? Prompting is everything is actually very true. People have moved a lot from, like, prompt engineering, but prompting, because prompt engineering right now is a problem that people feel that they understood. Earlier, if you want to get an agent to work right, it was always a prompt problem, right? Uh, Essentially, people always say if you want to get very good outputs, write better prompts, right? Prompts can be very structured, unstructured. Unstructured usually doesn't give you very good results, but structured prompts actually gives you a good results, right? So it moved from being like very plain instructions to other techniques that people started using, like in context learning, where you put all information inside there. Then chain of thought prompting, few shot prompting. You can also ask it to do retrieve information and then do things also, which is also sort of like in context learn prompting and all of those stuff. But if you really want to understand all the other different prompting guides that's there, one quick Google search on, like, prompting guides, right? It would take you to this particular website that actually tells you what are the different other prompting techniques that are there, right? Three of swords, meta prompting, but meta prompting is not something that you will probably end up using when you're building agents, but depends, but yeah. Um, Essentially, prompt engineering is a problem that people feel that they have solved. It's an old problem, but still a valid problem, right? Then people moved into something called, like, context engineering. It's also prompt engineering one way or the other, but it's about solving the context window problem, right? Because you have to give it the right tooling, um, whether you have to use subagents to do everything is because you don't want to pollute the context window. Um, because people have noticed when certain thresholds on a specific context window has been passed or, like, reached, then the model gets dumber. Then they started, they coined this term called, like, context rot. So then they got into this, okay, since we have to actually keep the context window very clean, do we give it to subagents? What are the right tools to give? How do we prevent the LLM getting the wrong information, wrong idea? How do we prune this? How do we compact this? And all of those stuff, right? So 2025 became like a context engineering problem. It's essentially giving your agent or your LLM a finely assembled set of instructions plus follow-up messages along multi-turn conversations, right? Because when you have, like, an agent on a loop, what's basically it's just reading its past information also. If your past information actually is big, then your context window increases and your new messages might not benefit from the model's intelligence and all of those stuff. Then you look at summarizing it or removing it or truncating it and all of those stuff. Then when you summarize, truncate, or even compact, say this thing, or remove, then the problem comes in is what is the techniques that you should be using so that we don't remove or summarize wrong information and we don't remove important information, right? That's where context engineering became a thing and people started treating context windows as the prime way of getting agents to perform better, right? So that's why they usually tell you don't put a lot of tools, uh, because most of your context window is already polluted with this tool information. Start using CLIs and give agent CLIs to use and all of those, right? So essentially, what is the right information that needs to be put in system prompts or user messages so the agent would actually do the right work. Now, recently, things has been around harness engineering, right? people have realized, okay, it's not only the prompts, it's also not only the context windows, it's not only the tool things that needs to be taken care of, but it's the entire loop that needs to be thought through, right? That's where the whole concept of like harness engineering comes into play, right? If you're building an agent to do finance, to write storytelling, to write copywriting, social media management, what are the right tools that you should be giving? Are you supposed to give tools, or are you supposed to do skills where you give specialized workflows as prompts where the agent would read, understand, and do things, right? So right now it went from tuning the behavior, went from that to giving the right thing in messages. And now it has actually evolved into how do you treat this as an entire system that you give it the right primitives that the agent would work as it is, right? So for an example, if you look at Claude code, what if you look at Claude, if you use the same model, let's say you use Claude Opus, Claude Sonnet on Claude Code, Open Code, Pi, GitHub Copilot, you might find one does it better than the other, or two does it better than the other, or one is excellent, right? Is because that coding agent is a harness itself. Its system from the tools that it does, the skills it has been packed with are the ones that actually define whether the system is good or not, right? So for an example, we are building a harness around how to have very good conversations. How can we, and we're also extending that to actually have that in a way that how this agent can be actually used to build agentic commerce, right? Because I can't build an agent that can't converse properly to do the entire end-to-end sales pipeline of like a salesperson, right? So we pipe in the right information, right skills, right tooling that we ended up building our own harness, right? Things like that. So the more that you actually realize, sometimes out of the box tooling is always not the best tooling that's there, right? You might actually have to use those tools and build uh, layers so you can treat the entire framework, entire things that actually comes into it as a harness, right? For an example, this entire supervisor thing that I've built is can be itself an autonomous agent where you give it a feature, it understands what is there in your file system and fixes bugs, right? You can break it down into different phases, add a workflow around it, and do a lot of other things, right? I can have a separate harness which keeps track of, okay, this is the current agent that's there. Okay, this agent output is not good. I'll pass it to the other agent, right? Things like that, right? I was a very dumb way of telling it, but I just put it down in like very small terms how this single agent itself can be properly done as like a proper harness itself with the right tooling that can be given, right? Okay. Uh, right now people are shipping a lot of things, like people are shipping skills because Cloud Code, Codex, if you listen to all of this news that's around, they're trying to build the perfect harness for like everyday work. So people right now are taking a step back and actually building skills around it. So this entire thing, right? So this entire slides is actually built using something called open slides, right? If you want to build videos, you can actually use something called hyperframes, right? Remotion, slide dev, all of those stuff. So people started writing plugins, started writing skill files as a way of distribution also. So for an example, I want to make like a product video. I don't have very good uh, I don't know how to make a video. I could probably give these skills to my coding agent so it can figure out on how to use that tools, right? So that's where this entire thing of you building a harness around it, where you extend it by using skills and plugins, can be very beneficial. So this entire slide that you're looking at right now is actually built by something called OpenSlides, right? Okay. So just to recap things, right? End of the session took an extra 10 minutes. So if you look at it, workflows are scripts with LLMs. What that essentially means is you are the ones that are writing all of these workflows, right? Which governs control. Inside each of these workflows, you can actually have an LLM embedded in it to do intelligent tasks if at all needed, right? You really don't need it, but if at all needed, you can have just workflows even without LLMs, right? Workflows are just directed graphs, right? Just graphs in general, right? A sequence of step that needs to be there. You can branch off of something, you can do conditionally, you can loop back into each of these graphs also if you want, right? So do you remember this loop control? I didn't show it, but you can do like a if if else in the branches also, you can actually go back to a previous branch uh if you want to, and you can do it as a loop also. So agents are LLM with scripts. They are basically a model that's deciding to complete a specific task. I have these tools, I have these functions written. How do I use them? Right? So it makes its own decision, right? So all these same six primitives, the model, tool, memory, loop control, evals, is the simplest wiring that you can actually think of when you're working with building agents, right? Everything else is up to your creativity and your engineering skills, right? But these are the primitives that you actually need to know that will take you a long way to build these systems, right? Models, what are the LLMs that you have to use? How are you going to use it? Are you going to write your own LLM calls? Are you going to handle all the tool calling by yourself? Are you going to use a framework? If you choose a framework, the entire six cycles are taken care of for you, right? You don't have to worry about it. If you're doing it from scratch, you need to think through about everything that you do, right? So people talk a lot about OpenClaw. I don't find OpenClaw very fancy, but I find the Pi coding agent very fancy because Pi is actually like OpenClaw is actually built on top of Pi, right? Um, uh, I am assuming everyone knows what OpenClaw is. OpenClaw, at least since you guys are in tech space, I think you might have heard of OpenClaw. Um, but if you still actually haven't, let me bring this up. OpenAI acquired the guy who made this, so the product went to him also. So what actually happens is it's a set of it's an agent that has a messaging layer on top of it and has the right set of tooling around it to do autonomous tasks, right? For example, you can actually ask it to run your own business, fix things, uh, do anything that you want, right? And mostly is because the skills and the things that it actually has, right? So this is a proper harness that actually has been built around, but it's actually internally using Pi, right? It's basically using this simple, not, I wouldn't call Pi simple, but I find Pi more sophisticated, or like I find Pi more interesting than OpenClaw, to be very honest. It's because of the primitives that OpenClaw provides, like Pi provides, is what OpenClaw is using internally, right? If you go inside, OpenClaw is open source. You can actually have a look at it, right? There's a lot of engineering that's going behind the scenes. I'm not saying that it's bad. It's just it's a wrapper around. I'm not saying it's a wrapper around Pi, but it has its own engineering around it. But you will notice that most of the things that's actually been taken across is actually done on Pi, right? If you go inside the SDK a lot, funny, I actually saw this somewhere. I actually have this documented. I don't know which package it. was used. I don't know. It's not the SDK. Sorry, I'm looking at the wrong package. Um, okay. So this entire thing that they actually built on top of is their tooling around Pi itself, right? If you really want to look at it, you can always go inside the docs, right? If you search in this, like OpenClaw, right? You will see that they actually have built OpenClaw using Pi itself, right? So Pi can be actually used the same way that I actually told Mustra can be used, right? You can actually use it as an SDK if you want to. These guys are actually using this as an SDK, right? The easiest way is actually to copy this, go inside the OpenClaw thing, right? And see how they're using it, right? You can learn a lot in terms of how they have taken a very small SDK and built like actual systems on top of it, right? Like I said, they're using Pi, but they are building a lot of things on top of Pi. So it itself is like a properly built harness, right? Okay, that's it from my end. Um, if you can play around with this, right? I would, like I said, I would suggest you walk backwards from the supervised agent until you find the small, simplest things that actually connects everything together, right? That's the main reason I actually walked backwards, is because when you understand how something is working by reverse engineering it, you will learn a lot, right? So we looked at the supervised agent, saw an entire workflow with it, or like entire chat with it. We saw what tools it called, why it called it, what results came out of this call, what are the agents it used it, why did it use it, is because of those descriptions and all of those stuff, right? Then we went around going through each of those individual agents and we ran them separately. We ran the workflows and all of those, right? If you I'll fix the demo agent. The demo agent was working the last time that I did it. So I think it should work. But what I'll do is I'll have another look at it. If you are lost at any point of time, you can always go and ask the demo agent how to run this code. It has enough information for it to tell you to on how to do it, right? And at any point, if you feel that your model is doing dumb things, right? Because you're using a free model, uh, you can go inside this demo agent, right? So this is actually using OpenRouter itself, right? If you really don't want to use OpenRouter, you can actually go to Gemini, right? AI SDK, um, Google, right? You can actually replace this with the Google AI SDK, right? You just install this, import this, right? Import this, follow its documentation, right? You just have to do this, right? As simple as this, right? And replace that here, and then go into AI Studio, right? You can get a API key if you want to, right? Um, I think it's free. Otherwise, you might have to create like a billing thing, but you can use Gemini's API key for free. You can provision your own API key from there. Okay. So you just come here, create your API key. I already have a billing in place. Because of that, it doesn't show up. It's already shown here. Otherwise, you have to go ahead and create like a billing plan. I think it should be free. If it's not free, everyone has a debit card at this point of time. Just add your debit card. They give you a generous fee tier that you can actually use. If not, just stick to the uh, open router free models that you can use, right? Um, if not, just use something like Grok or Cerebrus. All of those connectors are there, right? Just switch these models if you don't want to pay for it. If not, if you want to run the way that I'm running this, you have to create like an API key from Open Router, right? you have to top it up with a bit of credits, right? You sign up for Open Router, create your API key, right? And put your API key inside the .env file, right? I'm not going to open my you know what? I'll open my env file and I'll delete this. Essentially you have to, at this, it's all documented, so you just have to follow this. Just go into create, right? Do whatever it is, like call it, sorry, demo API key. After you click on create, copy this and just paste it here, right? Okay. I'm going to delete this since people are recording. Delete this key. Delete this key also. I think I probably might have spent around $3-4 to show, like $2 to show this demo. While testing also, but I think $1 should be more than enough to actually run the entire thing. Okay, sounds good. But you can always use the free models that they give. Um, I think there should be open router. You just find one of these free models and you can actually swap it. I would highly suggest you to use like GLM 4.5 here, I think, or Minimax. I think that's very good at tool calling. Or you can try this. Apparently, this is free and is very good at programming. Anything that's good at programming is very good at tool calling. Seems this is also very good at tool calling. So you can actually use one of these stuff, right? And replace the model. For an example, if this is the model that you want to be using, click on this, copy this, and uh, change this here, right? Simple as that, right? No, everything is documented. I have also documented the open router thing. Um, you just go ahead and do that. If you want to change the default model, you can always come ahead and change the default ID here, right? You can change that, right? So if you want to play around with the models, that's how you would do it. Just go to one of these free models, click whatever that you like, copy this and change it at the default model ID. And also change it at, if you're using the demo agent, then change the demo agent to that also. Cool. Open for any questions if you guys have. If not, that's it from me. Okay. Since there is no issues, we can wind things up. Uh, you can always reach out to me by searching for Mithushan Jalangan anywhere. Um, if you just Google me out, you'll mostly end up finding my LinkedIn, or just search for LinkedIn directly, and you can actually message me there if you guys want anything. Right. Thanks, guys.
Thank you very much, Mr. Mithushan, for that insightful and engaging session. We truly appreciate you taking the time to share your expertise with us. As we come towards the end of today's session, I would like to invite our co-chair, Chamat Kanishka, to deliver the vote of thanks.
Thank you, Vidya. Good evening, everyone. First and foremost, I would like to express our sincere gratitude to our speaker, Mr. Mithushan Jalangan, on behalf of our organizing team. Thank you for an insightful and engaging session. Your expertise and practical perspectives have given us a clearer understanding of the role of AI agents in modern workflows. We truly appreciate your time and effort. I would also like to thank our organizing team for their dedication in making this workshop a success. Finally, thank you to everyone who worked behind the scenes to ensure the smooth execution of this event. Once again, a special thank you to our speaker. Thank you all. Have a wonderful evening.
Thank you, Chamat, for the heartfelt vote of thanks. And with that, we come to the end of our first workshop session of the Developers Summit 2026. Thank you everyone for joining us today and making this session a success. We hope to see you again in our upcoming sessions. Have a great day ahead.